Hi, T2W here, and on this how-to video, I wanted to show you how I built my own do-it-yourself, cost-effective power panel for my KLR 650. Stick around and we'll get started right after this. So here's my existing power module that I have on the bike. I had ordered it from Amazon, and it has about it was about $15, so it was not a very expensive unit. My biggest complaint about it was the mounting. As you can see, the mounting is not very secure. It kind of rocks back and forth. It's just mounted using a little plastic clamp that goes around your handlebars. Now, it has not fallen off. I've never had any trouble with losing it or anything. I've had this unit about 1.5 years. It still works well. It's just not the best solution that I'd like to have, but it does work. It does have USB on this side. It has 2 USB ports, and on this side it does have a traditional 12-volt cigarette lighter type of power port. It's serviceable. It works. It's an inexpensive solution. But I wanted to come up with something a little bit better, and that's what we're going to get into next. Okay, I wanted to show you what I ordered here from Amazon. So this is by Klena, and there's the company name, CLLENA. I'll put a link below to it, but I want to show you what you get. So what comes in this is you get this, and again, it's really for marine and other applications outdoor. So you can put this in your truck, you can put this on a ATV, you can put it in a boat, whatever. It comes already in this nice, with this nice mount that the 3 units are in. So the 3 units that you get are a 12-volt plug, typical cigarette lighter type of 12-volt power outlet. You have the voltmeter here. This lights up, of course. And then over here, which is what I really wanted, was USB. Now the charger unit that I have on my bike already has USB in it. But if you pull this plug, which seals it nice and tight, that's a little crooked here, but you get 5-volt USB, and I don't know if you can see it without it being lit up, but this top one is a 1 amp, and the bottom one is a 5-volt 2.1 amp for things like tablets, higher capacity phones, etc. So that's super nice, and this is illuminated as well, so you can see it better in the dark. Again, it has the watertight plugs that go on them. In the package, you also get the screws to mount this bracket, the 4 screws, as well as the wire ends, the spade ends that go on these spade plugs in the back of the devices themselves. Now, I looked on my bike, and I really tried looking at a place, even if I oriented these up and down or this way. I looked for several ways to mount it. I couldn't really find a place that I was happy with that you could mount it. Now, in the upper fairing of the KLR, you could drill some holes in the fairing itself and mount some of these, but if I ever wanted to remove those fairings, I didn't want to have to worry about unplugging the wires. But I was really inspired by the KLR dash, their lower dash. Those guys did their research, and they picked a really good spot to mount these. Again, the main thing I wanted was the voltmeter and the dual USB charger. I rarely use a 12-volt power plug, and on the KLR dash, that's all they offer you is 12-volt. So I could have bought the KLR dash for $115 and then replaced this, but this unit was $24. I got it off of Amazon. 24 bucks for this. It's really nice. And then all I had to do was to make a template to fit these and make my plate. So to make my template, I just used an old gift box and then applied the measurements to it and then sketched out my design. Then cut it out, and then I used this template to transfer the measurements over to my piece of steel. Once I had it transferred over to the steel, I then used a hole saw to cut out the holes to mount the power ports in, and then cut it out on the bandsaw. At this point, I'm going to fast forward through the fabrication process as not to take up too much time on the video. Okay, so just to give you a close-up here, I've got the bracket made, and I've got all of my different modules or power fixtures in here, just to give you an idea of what it looks like front and back before I go ahead and paint up the bracket. The nice thing is that this voltmeter sits very low, so it won't give me any problems. These are pretty long, but there's enough room where I'm going to mount this to allow for that. So next, I still need to drill the mounting holes down here in the arms of it to go in the upper fork brace. And then I will bend these on my brake press to the right angle, and then prime it and paint it up. Of course, I'll be removing these while I do that. I just wanted to show you, give you an idea. The 16 gauge aluminum or steel is just about right. I think it's thick enough, it's rigid enough to remain thin and yet sturdy, so I'm pretty happy with that. All right, so here I've got the part painted. As you can see, I've got the arms bent down. Just have it suspended on a piece of wire here to do my painting. Just hit it with a couple coats of this Rust-Oleum high performance enamel. It's supposed to be industrial strength, we'll see, but tough so that it won't chip or scratch. So that's nice. Anyway, it's looking pretty good there. I'm happy with the way it's turned out. So now I'm just going to let this dry thoroughly for about 24 hours, and then we'll start the assembly of the all the gauges and the outlets and the wiring. Okay, so now I want to talk about how we're going to be hooking up, making the electrical connections for the power unit. My existing power unit I have running into port 1 of my Rowe Electronics PDM60. I have this on the bike. It's a very cool little device that eliminates the need for running everything directly to the battery. So how this PDM60 works, and this is just a very quick overview. You run it in and you make your power connections to the battery, both your positive, and then you have your negative. You have this bus connector, which all of your grounds tie into for all your various devices, so not everything is running directly to the battery terminals. Additionally, this also eliminates having the need for fuses on each of your accessory devices. So instead of having a bunch of the different fuses everywhere that you have to worry about, the PDM60 acts as your fuse box and also your power distribution module. Additionally, you can program each of the 6 interfaces on it to do different things depending upon your different device. And by doing different things, I mean things such as having a delayed start. So on my auxiliary lights, I have it delayed where it turns on, so that it does not, even if I have my lights turned on, when I go to start the bike, all of your power is dedicated to starting the motor. So I'm only using really 3 of the 6 currently. So the PDM60 is pretty cool because you can do delayed start, you can set it to where it's on, you can set your amperage, how many, what amp fuse you want, like 5 amp, 10 amp, 20 amp, whatever the case may be. And I'll show you what happens here. So when you turn the key on, there's a delay on the PDM60 before it powers up. So the key's on now, and there's a delay, and here we go. So you can see which have ports. So all of the green lights means there's a device connected to it. The red lights, I don't have anything connected on those, and those ports are disabled currently. So I have this set up as a delayed start. It gives you a chance to start the bike and have the engine running before any of your auxiliary devices are keyed on. So if any of them quote unquote blow a fuse, what it does is you'll see this turn yellow, which port. And in order to reset the fuse, instead of having to pull over to the side of the road and pull the seat off and dig around and find which fuse is blown and then look for a replacement fuse and plug it in, all you simply do is pull over to the side of the road and you turn your key off. And you'll see my key is off now, and there's a delay, and you'll see that number 4 is still powered because I have it set to where my auxiliary lights will stay on for a certain period of time so that I can set up camp or whatever the case may be. But anyway, by cycling the key and then turning it back on, it will reset the fuse that has blown, so to speak. And there we go, we're back to a normal state. So very handy little device. I'll do a more detailed video on this at some point. Maybe, like I said, I've had this for over a year and it's worked well. So my point about talking about the PDM60 initially is that right now I have coming in on the white wire here, which is port number 1, I have my power ports hooked up to this. So my new power configuration, I think I'm just going to run it straight to the battery, and here's why. You can configure a port on the PDM60 to be hot all the time, on all the time. But by doing that, it does create a 50 milliwatt draw all the time on your battery or your power source. So if you, like me, on a motorcycle, that would be a constant draw on the battery. That's not good if you don't have a battery maintainer to plug in, or if the bike's going to sit for extended periods of time. I think I would get by with it because I do keep a battery tender to maintain. I have an AGM battery in here, so I keep the battery tender plugged up to it. But even that, if I'm out camping or whatnot, or out away from home for extended periods of time, I don't want that 50 milliamp draw to be affecting. So what I'm going to do is, instead of running my power ports through the PDM, I'm going to run it straight to the battery in this particular case. Now, all of my other devices will continue to run through the PDM because it's great for that. So right now, the way I have it set up is that my power ports are running into port 1. So when my key is off, I have no way. This kills the power to that device. So I have to have my key on in order to charge anything. Initially, I thought that was going to be a great way to hook it up, use the PDM. But then I found that when I'm out camping for extended periods of time, a lot of cases you'll want to charge a device, whether it's your cell phone or GPS or whatever the case may be. In situations where you may not be riding all day to charge your phone, you will want to charge it. So I'm going to run it straight to the battery and I'll have a switch on my port so that when I want to charge something, even with the bike completely off, I can turn the switch on. It will draw power directly from the battery. It will charge my devices. And then when I'm done, I can power that unit off. So I'll manually be able to control the on-off. That's going to be better, again, for camping or whatever the case may be when you want to charge something when your bike's not running. All right, so enough about this. Let's go ahead and disconnect this old unit and get started hooking up the new unit. Okay, so to disconnect my existing power module, again, as I told you, it's running through the PDM. Right now I have the power off on the bike, and therefore the power is off on the PDM60, and it's killed all the power to any of my devices. So the hot lead goes into one of my existing lead. In this case, it's the white wire, or port number 1 of my PDM60. That's the hot lead. As you can see, it's currently running here. It's soldered and sealed with the heat shrink tubing. The negatives all go to this pigtail that comes with the PDM60. So this pigtail runs down to the negative post on your battery. And if you just pull this hood back, you'll see there's a bolt, one lead. So every ground for any of your devices, in my case I have 3. So right now I have my power unit, which is my USB and 12 volt power supply. I have my heated grips, and then I have my auxiliary lights, the LED, the rigid lights. All 3 of these are running in and terminate right here on this one ground. So what we're going to do is to loosen this, this bolt here. Weave that out, come over here. Now my ground is disconnected. Here is the power supply going into my lead 1. I'm just going to clip that back short of the connection here. I will put a little bit of liquid tape on that just to seal that connection, and then I will to seal this end, and then I will roll this up like the others, other spares that I have in here. So I have all of my other connections in here, and I just have them rolled up and cable tied so that they don't just run all over the place. Now, the PDM60 is designed to be mounted on the back. You'll see this is the programming port where you have to plug into if you want to change the programming. It has the mounting ears where you can mount it to a frame or somewhere. The best place that I found on a KLR, I couldn't really find a good place to mount it, so I just leave it here under the seat. I just lay it in this little recess right here. This is the rear fender coming down. It's been riding there for, like I said, well over a year. Haven't had any issues with it. I just make sure that all my cables are tucked back here. There's a clamp that's missing here right now that I've removed to the purposes of this video. But just make sure all my cables are tucked down nice and neat, and then it just rides right here under the seat, and it hasn't had any problems. And it's loose so that I can get to it, flip it over, plug in the programming if I want to change the programming on the PDM60. All right, so I'm going to remove the old wiring and run the new wiring, and then we'll make the connections and be good to go. Okay, so here I just want to show you the difference between the two units. This is my old unit that came off the bike. A little closer look at it now that I have it off. Again, here's this plastic ring that went around the handlebars, and then there's a little lever that you can slide it on and off, which was kind of a nice feature. And then we had the rocker switch on the top where I could turn it on and off with a rubber cover to help make it waterproof. I ran this unit in rain, dirty conditions. Again, it was functional, never had a problem with it other than the really questionable mounting. It never came off or came loose, but it was just not as sturdy and as rugged as I would like. Like I said, for about 15 bucks off of eBay, Amazon, $15, it was a good deal, and it lasted me for over a year, and it would have continued to provide service as far as I know. Never had any trouble with it, but I just wanted something a little more permanent, and so that's why I built this. Now this looks a lot like the KLR-lower. In fact, that was my inspiration. I already had purchased the power modules, but the mounting bracket was an inspiration by KLR-, their lower dash unit. It was simple to make. Once I got all my measurements, I just took a piece of 16 gauge steel and fabricated this, cut it out to fit, drilled all my holes, bent the tabs down so that it would mount on the fork brace, and I'm quite happy with the way it turned out. As you can see, I have a voltmeter in the middle, which is one of the great things I wanted. I always felt like I was never quite sure how my charging system was working, even though I've never had any issues with it. I just wanted to be able to see. So right now I have this powered up to a 12-volt DC power supply. I put a switch over here to be able to turn this unit on and off, like I talked about earlier. I wanted to be able to manually control whether the power was running to this or not, so I just have a waterproof rocker switch here, and when we turn that on, you'll see the unit powers up. The voltmeter reads up to 24 volts. Not that you'll need that on a KLR, but it does give you the percentages. On my power supply unit, I can actually adjust the voltage. So you can see as we go up and down, when you get down below 10, you'll get like 9.55. If we want to go up like 13, 14, I've checked this against my benchtop DC power supply. And the readings are pretty accurate. It might be slightly off by about 0.05, but other than that, it reads pretty accurate. So again, you'll get a real good idea as I turn this up and down of what your charging system is doing. The reason I wanted that, so that if I'm running my lights, my heated grips, and charging a phone, I want to know what it's doing and how much voltage is in my battery. So that's the other reason I want to run this directly to the battery, is so this will read accurately what's my charging system doing. So on the right, I have a 12 volt. I put the 12 volt over here on the left-hand side because I don't use that very often. In fact, I have nothing that I plug into it, but I wanted to have a 12 volt on the bike in case I'm traveling with friends and they want to charge something they can plug in here. To the right is my USB, and when I pop this open, you'll see that that's also illuminated. Let me turn off a few lights here. You might see a little better there, but that is also illuminated, so that at night I want to know whether to be able to plug the USB in. The top one you can see is 5 volt 1 amp, and the other one is 5 volt 2.1 amp for tablets and other higher powered devices to charge. So on the back side, we want to take a look at this. Here's how I have it wired up. This bundle will obviously not be there. It'll run down, but it was pretty simple. I just came in to my switch, of course, and then from the switch, it powers out, goes into the voltmeter, and then from there, I branched out to each of the individual units. The switch has 3 connectors because the switch will have a ground, of course, and your ground needs to be shared between the ground to these devices and the ground to the battery. Then you have your hot lead that will go directly to the battery out here. And then you'll also have your accessory, which is your switched lead last, and that is what goes out to all the devices to power them. From that point forward, you come into here and then split out to the individual devices. So power the voltmeter and then go out to power your power outlet devices. And that's it. I tried to tuck everything in. I used liquid tape on the back of the connectors to make a waterproof seal, and just tried to wrap everything up as neat as I could with a cable tie around this. And then of course this lead is what will go out and down to the battery. Now right now, since I won't be running this through my PDM60, I do need to make sure that I have a fuse on. Let's turn this off and set it over here to the side. So you'll need to make sure that you have a lead with a built-in fuse on this. This is a smaller one with a 5 amp fuse, which I may use that. And then I also have another one. And these are from various projects. You can buy these, but I've got these left over from other projects that I've done. Since I run other things to my PDM60, I've always cut these off and just put them in a box and save them. Here's one with a larger 15 amp fuse. But that's the one downside of this. I'm running straight to the battery. I will have a fuse on here, so if that ever quits working, I'll know that I need to pop this off and check to see if my fuse is blown. All right, so that's it. I'm going to go ahead and get this thing installed on the bike. Okay, so now I have my plate mounted up here on the fork, and as you can see, it turns with the fork, not hitting. Pretty clever design. And I have the wires run back, so I can reach over here and turn this on. As you can see, it's plugged into the battery now, so it's showing 13 volts on my battery, and everything is good to go. I did run the wire down. Let me back up here. So for wire routing, I came down here, followed the wire loom with the rest of the cables that come back down and to my battery. And let me get over here closer. So the wires are coming down through here. Everything is cable tied, tucked in as close to the frame as I possibly can get it. If you're going to run cables, just be aware of this puck, this rubber puck here that the tank sets on. The tank needs to be able to slide on and off. It's a tight fit. So you don't want any wires loose along here that can be grabbed by that mount on the tank, snagged or pulled. So that's why I have everything cable tied and tucked in here as tight as I possibly can get it. It runs on back here, and have it coiled up the excess, have the inline fuse, which is right here, so that I can get to it relatively easily if I have to. Everything is tied in. This clamp is back on now, and as you can see, the rest of the cables go back here. Put some liquid tape on the end of this cable. I'll tuck all this back in here nice and neat, and we'll get the seat on, tank, and lower fairings, and we'll be good to go. Okay, so I hope that was helpful. I know there was a lot of extra information in there about the wiring, but I've had a lot of requests from viewers saying they would like to see more about how to wire things up, accessories, because I didn't really go into a lot of detail when I did my lights and heated grips, that sort of thing. So here I wanted to give you a little more detail about that. Also, one other thing I wanted to add is that I spent a total of the $24, a little less than $24, just for the power modules that I ordered off of Amazon. I already had the 16 gauge steel here in the shop. I already had the paint and the wiring from other projects. So if you had to buy those things, it would cost you a little more than $24, not a lot. You could easily build this whole thing if you bought it for, I think, under 50 bucks. So, you know, for those of you like me who are do-it-yourselfers and like to make your own stuff, then this is a fairly easy project to do. I want to be very clear, I'm not advocating that you don't buy products from KLR Dash. I just wanted a different configuration than what they currently offer, and I already had the USB ports and that I'd ordered from Amazon, so it was an easy step to just build a mounting bracket for it. If you don't have the ability or the tools to make this yourself, then by all means go to KLR Dash and buy their lower dash product. It comes pre-wired. All you do is mount it to your forks, you connect it to your battery, and you're ready to go. But for those of you guys like me who like to do it yourself, then you know, this is how I did it. So anyway, hope this was helpful. This is Tim Two Wheels. Thank you for watching.